It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Okay friends, so this was the informative video on our Unacademy Combat as well as our iconic plans. Okay, so I hope you got the relevant information, and yesterday only we had our Unacademy Combat at 11 a.m. Okay, and it is there at alternative weekdays. Okay, so next Unacademy Combat will be live on after 14 days. Okay, so you can enroll yourself in Unacademy Combat and you can actually get your actual rank. Okay, so for doing that you may use my code which is written here as 10 free of cost. Okay, चलिए चलो सेशन स्टार्ट करते हैं. Let me give my quick introduction. I am your friend Aishwary. Used to teach you for GATE and ESE. I have done my MTech from IIT Delhi and BTech from Jamia Millia Islamia. 4 times I have qualified GATE with my best AIR 226. I do have 7 years of teaching experience and 2 years of industrial experience, and all these are the subjects which I am basically taking on Unacademy official YouTube channel, Unacademy special classes, as well as on Unacademy Plus. The subjects are theory of structure, RCC, Geotechnical engineering and strength of material. Okay, so my dear friend, this is a code which you can apply before buying any Unacademy Plus subscription, not only in GATE and ESE but at also various other competitive field. So you can consider this code as an universal code at Unacademy. You can consider this code as a universal code at Unacademy. So one information I want to pass on, that this 10% discount is soon going to be converted into, you can say, 5%, and it can be anytime, even today, tomorrow, and upper limit is 1st of March. If it is not going to be 5% next 5-6 days, then definitely on 1st of March the discount would be only 5%. Okay, so now the question comes into mind, why do we need Plus? So at Unacademy Plus you can access to our daily live classes, crash courses, weekly tests, doubt solving sessions. So in both the languages we are running our courses, and rank improvement batches are also there. And if you want to convert simply this Plus experience into your personalized coaching, then you can go for our iconic plan, where we are assigning you a personal coach, which is also known as your local guardian, who is going to plan your studies, who is going to keep the study booster session for you, who is going to analyze your test at the personalized level. And not only this, you will also be getting the specialized notes and practice sets on the daily basis. Okay, so whether it is a matter of Plus or iconic, so my code S10 is readily available there. Okay, so these are the informations on our upcoming batches, that this is 22 Feb. Okay, means from today only, my dear friend, we are starting our 5th batch, or for gate 2022, our 5th batch on gate 2022. It is a 1-year program. The batch name is Evolve batch. So you can see that today only it is going to start, and if you want to enroll, if you want to enroll yourself, so you can use my code, okay, for taking the subscription. And if you are planning your preparation in 2 years, or you are targeting gate 2023, in that case a batch by a similar educator, same educator, has also started, and it is known as the Ascent batch for 2-year program, and it is 22 Feb. Today only it has started. So for 2-year subscription and all, again you can use my code. And if you are targeting engineering services, my dear friend, then you cannot even think of escaping general studies, because general studies is the one which is really going to create the difference in your rank. Okay, so that batch we have started recently, or you can say 18th of February, and here as well you can take my code, okay, for 10% discount. Okay, see, if you have not downloaded the Unacademy learning app right now, then in that case I would say you have to download it, because the lot many stuff, quizzes, combat, okay, special classes which may be relevant to your exams, so these are being conducted free of cost on the Unacademy learning app. Okay, so download it from the Play Store, or you can say from the App Store, and after downloading you can always use my invite code S10, and you can unlock your free basic accessories like special class, quizzes, combat, as well as live test series. Okay, so all these things are going to be at free of cost. Okay, is it clear to all? Chaliye. Shabin, okay, good morning, dear. 9:06 a.m. you have replied me, and time is still under 9. Sorry, okay. Okay, so today is session number 20, and the name of the topic is permeability by field method, or you can say it is simply a continuation to well hydraulics. On Friday we had our last class. And we discussed the introduction to well hydraulics. Okay, and today I'm going to revise all those stuff, because on that day I was not having presentation, and also lot many time was there, so we can also revise this stuff, and after that we will be starting calculating the permeability by field method. Okay, chaliye start karte hain. Okay, so just a revision, but before that I want to tell you that where we are on syllabus. So we have already completed origin of soil, phase diagram, soil classification, mineralogy, permeability. Maybe by today's class we are going to wind up. After that, from tomorrow onwards, I will be starting your C page. So from tomorrow onwards, you will be starting C page. After that, I am going to take your next chapter like effective stress, compaction, etc. Okay. So अभी तो 30% हुआ है geotech. You can say like that. Yes. So we have studied that for determination of coefficient of permeability K. Okay, we were having three methods: laboratory, field, and indirect. So on laboratory we have seen. On laboratory methods we have seen. You can say fine grain soil test, like falling head test and constant head test. In indirect methods we have seen the various equations. Now for field test we are studying well hydraulics. Field test, because here we have to excavate some well and we have to draw down the water, and after that we have to observe what is the drawdown curve. Now what is the type of aquifer, then how much time it is going to flow the water from point A to point B. So based on that we are going to find the conductivity of the soil. Okay, so that is the case. So here you can see, so well hydraulics we were starting, and so the very first definition which we studied on that day was aquifers. Okay, basically we have to deal with aquifers only. What are aquifers? Aquifers are basically your porous and permeable formation which have water storage and water seepage capacity both. I discussed that on Friday, that which are permeable as well as which are porous. Permeable, which can pass water, or porous, they are known as you can say aquifer. Okay, a best example of these are sand and gravel, and there are two types of aquifer: unconfined and confined. Unconfined is just like they are starting from the top and they are not having any confinement. But confined aquifer means here the sand or gravel layer is going to sandwiched between, it is going to sandwiched between two impermeable layer. So in that case you have to say that confined aquifer. One thing I also told you that in unconfined aquifer the pressure variation was hydrostatic, but in confined aquifer your pressure may be even higher than that of atmospheric pressure and all. It may be higher than that of hydrostatic conditions. Okay, it may appear like that. Okay, so next definitions were, sir, can I ask a doubt? Yes, David RK, of course, I am here for doubt only. A very good morning, Shamala. Very good morning. Yes, you can ask your doubt, dear. You can type it. Yes. Next I was saying acuclude. What are acuclude? Acucludes are porous but they are impermeable. Means which can retain the water but they will not be able to, you can say, pass the water. Or such example is clay. Next is acutard. Acutard means they can retain the water. They can pass the water but with very less velocity. Okay, like clay is having very less velocity and silt is also having less velocity, but still it is higher than that of clay. So silt, the funda is very simple. As you are increasing the particle size, your void ratio will be decreasing. Okay, but interconnectivity of the voids will be more. So permeability increases with the increase of size of the particles. Okay, and porosity increases, you can say the soil water retention power increases with decreasing size of the particle. So as we all know that the sizes of clay materials are even less than 2 micron and all. So definitely they are going to have very large void ratio, but interconnectivity of those voids will not be there. So that is the reason why clay is considered as porous but impermeable. So relatively silt is, size of the silt particles are relatively higher, like we can say it is up to 75 micron. So relatively they are higher than that of clay. So it's having porosity, but porosity wise it is lesser to clay, Permeability wise, it is greater than clay. Okay. Aquefuge, they are rocks only because they are neither porous or nor they are permeable. And if we are talking about, okay, before that I have see what David is saying. Sir, we want that void in the soil should be less, so the settlement will be less. Okay. On the other hand, in flocculated structure, there are more voids but less settlement, so it is preferred. Okay. Okay, then what is the doubt? On the other hand, in flocculated structure, there are more voids but less settlement. David RK, I would like to say on this that see, these are your flocculated structure, like say okay. So here void ratio is very high. No doubt void ratio is very high. Okay. So we do not prefer this flocculated structure. We prefer dispersed structure. Dispersed soil. Okay. Maybe you have studied anywhere. Can't say less void means less settlement. No. Less void means less settlement, obviously. But most of the time, your first statement is right. We are going to use only that soil which is having the low, you can say, void ratio. Okay, because low void ratio is really a very good stuff for your construction point of view, because settlement is less, so ability to water, flow of water beneath that is also less. But it is having only one drawback, that the amount of water which is already entrapped there, so that is going to take really long time to settle down. Okay, but which is the reference where we have seen that you are preferring flocculated structure? Flocculated structure are good in only one thing. They are having their initial, you can say, stress very high in order to break this flocculated structure into dispersed structure. So I do not think that flocculated structures are good. Maybe some relative thing, because initially they need a very high amount of stress to convert this flocculated portion into the dispersed portion. So maybe related to that constraint you have written these lines. Okay, is it clear? So then we can't say less void means less settlement. Yeah, that is all right. Less void means less settlement. Okay, less voids means are always less settlement. So, but if you have studied somewhere that this flocculated structures are preferred, so maybe the reference for that might be some other material who is able to take very less amount of sigma. So that may be the reason. Okay, so first statement is right. Once again I am concluding, first statement is right, that low void ratio materials are preferred as they are having very less settlement. And second statement, if we have read somewhere that flocculated structures are also preferred, then that may be with respect to those materials who are actually able to take less stresses. Okay, so I would like to say, instead of flocculated, go for dispersed one. Go for dispersed one. Okay. So next is the purged aquifer. I hope you got the answer. Okay. Next is purged aquifer. When water cavity or porous soil is sandwiched between two impermeable strata, then it is called the purged aquifer. Is it clear? Okay. Okay, you might have seen some springs, na? Whenever you are excavating some soil and you are getting a shower like thing coming out of the ground, so that is basically your, you can say, your purged aquifer. Okay. Study the thing. What is the specific yield now? So till there we have seen what is the specific yield. Tell me, anybody? What is the specific yield? See, yield means what? Yield means, see, by definition it is the ratio of volume of water which will flow under gravity from the saturated soil mass to the total volume of the aquifer. Means how much water, how much percentage of water can be actually transferred, okay, from a given mass of soil sample. That is known as a specific yield. Yield means extraction power. Yeah, exactly, Shabin. So the ratio of volume of water which will flow under gravity from the saturated soil mass to the total volume of aquifer, it is known as the specific yield. Okay. So you can say the volume of water which can be drawn under gravity with respect to total volume of the soil in percentage, it will be, is it okay? Okay. What can be the complementary thing to this? Complementary thing to this can be the specific retention. So that volume of water which is not flowing, in fact that is being retained in the voids against the gravity flow with respect to the total volume of the aquifer, or you can say total volume of the soil mass, is known as your specific retention. So your specific retention is equal to VWY okay, VWR over V into 100, VWR into V into 100. Okay. So one thing you can observe, sir, yield due to gravity or due to external applied force like bore wells or other process. See. Shabin, actually in definition it is gravity only. But one thing is sure, if specific yield of a soil is going to be good, then definitely due to you can say boreholes, external tube wells or pumping, it is also going to be more only, because gravity is that thing which is simply going with its own force with the help of the gravity component. If that yielding is more, then indirectly you can say then whenever you are going to do any pumping and all, still the yield would be higher. But yes, in definition of this specific yield, it only includes the due to gravity only. It is only due to gravity. But this is also true if a specific yield due to gravity is high. So automatically that is its water extraction capacity will also going to be high. Okay. Shivam Pandey sir 34.68 general category कोई chance है? No Shivam. Prepare one more time with good intensity. Don't even think of it. Okay. कोई chance नहीं. मेहनत करो अगली बार और कन्वर्ट करो इन 734 को 84 में. चलो. So one observation I can draw from here, that total yield plus total retention, if I am going to add, so it is volume of water, you can say yielded plus volume of water retained upon volume. So whatever water has been flowing and whatever water has been retained, so total they are covering the volume of what? So you can say that in percentage if you want to write. So if you are going to add your yield and retention, then it is going to be equal to the porosity in percentage. Tell me if I am right or not. Tell me if I am right or not. Then total it is going to be equal to percentage. Okay, because see now whatever water is flowing and whatever water is retaining for saturated condition, that is nothing but the volume of void, and we know that volume of void with respect to total volume is nothing but the porosity. So in percentage it is porosity in the percentage and all. Is it clear? But yes, it is true only for a saturated mass. It is true for saturated soil mass. Okay, so it is true only for those conditions. Okay, कोई doubt? Okay, now I hope no doubt till here to anyone. Any doubt to anyone? Okay, now see the next. Next is storage coefficient. Next is your storage coefficient. Okay, so storage coefficient, what is storage coefficient? It is simply the volume of water in a confined aquifer which is going to release per unit surface area and per unit change in head. So once again I am repeating. So the amount of water which can be extracted per unit surface area and per unit change in head, that is known as your storage coefficient. Is it clear? Okay. So definition is important, and symbol for this is capital A. Storage coefficient symbol is you can say given by capital A. And on field, how can we find the storage coefficient? Okay, so we can obtain at field by pumping test, that too in confined aquifer. Pumping test in confined aquifer. Okay, so by that you guys can get the storage coefficient and all. Okay, chaliye next, coefficient of transmissibility. Coefficient of transmissibility. Okay, so it is defined as the rate of flow of water through a vertical strip of aquifer of unit width extending to full saturated depth under the unit hydraulic gradient. See, in simple language I would like to say that coefficient of transmissibility, it is the transmissibility, it is denoted by T. It is simply your hydraulic conductivity or coefficient of permeability multiplied times the, you can say, width, height. Okay, it is the height. Okay. For example, if this is my clay and sand, suppose it is my aquifer, so this K value, whenever you are multiplying it with this B, okay, then this is known as your coefficient of the transmissibility. So simply you can say that if on multiplying your coefficient of permeability with the height or depth of the layer, you will be getting your T value, coefficient of transmissibility. Okay, and here my dear friend, B or you can say H is going to be the depth or height of the aquifer. Okay, so it's very easy to find. All we have to calculate K value, and after that we have to simply multiply that K value with our B. Is it clear? Is it clear? So once again I am reading the definition. It is defined as the rate of flow of water through a vertical strip of unit width extending to full saturation depth under unit hydraulic gradient. Okay, so that is the case. So now it's time to calculate all these stuff one by one. Now it's time to calculate all these stuffs one by one. Okay. So it's analysis of unconfined aquifer. As I have told you in previous class and today's class also, I have told you that there are two types of aquifer. You can say unconfined and confined. In unconfined aquifer, you cannot say anything about depth. Okay, And okay, yes, okay. You cannot say about the confinement, you cannot say about the depth. But in confined aquifer, your sand or gravel rail or your aquifer is simply going to sandwich between two, you can say aquiclude type of thing or two impermeable type of thing, and its depth is fixed and confinement is there. So there are two theories for these analysis, for unconfined as well as for confined. One is Themes theory and one is Dupit's theory. Okay, we will be studying themes theory, and we will be able to observe that Dupit's theory is nothing but a special case to themes theory, or you can say themes theory is to be the more advanced version, okay, of the analysis, and Dupit theory is simply going to be the special case of theme theory. Doesn't matter whether it is a case of unconfined aquifer or it is a case of confined aquifer. Is it clear? Okay. A very good morning, Pankaj. Okay. So I am starting themes theory. So what is themes theory? We will see. So first of all, assumptions in the themes theory. Okay. Although these assumptions would be more clear. Sorry. Sorry. Although these assumptions would be more clearer once we will be completing the theory, but still we can go through it. So okay, before reading this you can say assumptions, what I would like to do, I would like to draw a diagram. Okay, I would like to draw a diagram. See, unconfined aquifer we are seeing. So let's say this is my इसको बनाने के लिए what can I do? Let's say this is the ground level. We have to understand this diagram very carefully, because on this diagram only you are going to do the calculation and you are going to calculate the permeability and all. Okay, let's say it is my ground level. Okay, if I am doing the, you can say, themes theory, then what I have to do in these permeability determination things. First of all, I am having a well which is known as a test well. What you will say? A test well. This is going to be my test well. Okay. And not only the test well, we would also be having two observation well. Okay, in those observation well, we only have to think of we only have to study that how the water is going to be lower and what is the current water level in those wells. So those wells are known as observation well, and this is your main, you can say, test well. It is test well. Okay, means main testing is done from here only, and that observation wells are only for reading purpose. So let's say it is my first observation well. So with green I am drawing the observation wells. Okay, and let's say this is my second observation well. It can be on the either side. It must be radial. So one you can put here, one you can put here, because the everything would be circular. So it is circularly arranged. Okay. So better for understanding point of view, we can take on the same side. Let's say the water table be like this. This is my observation well 1. This is my observation well 2. So I can say this. It is observation well 1. OW observation well 1. Observation well 2. Is it clear? Okay. So you know the aquifer is unconfined, so you are not having any bottom thing or like that. So it is going to be very large height, and you have to draw your test well up to certain height only. So your unconfined aquifer means it is going to be very deep. Okay. Now see what would be happen. So before or just after the excavation, you will be observing that you are having a water level here. You are having a groundwater level. Maybe it is somewhere here. You are having a groundwater level. This is your initial condition. This is your initial condition before you start your test. So initially you know the level of the groundwater everywhere. Initially you know see testing is very easy. This testing is very easy. Okay. And initially you know the you can say level of the groundwater level. Okay, and it must be uniform only. And let's say that the various readings like this radius, distance between the observation 1 and observation 2, let's say, let me call it R1. Similarly, the distance between test well and observation well 2, let's say it is your R2. Only focus in themes theory on these terminologies. Duplicated is nothing but a one-line substitution of themes. This is going to be your R2. Okay. Now, procedure of test I am starting. So first thing, you are going to take out some discharge. When you will be taking the discharge, the water level here would be lower, and now it might have reached up to here, let's say here. So this green one is the revised water level, but surrounding, what will happen in the surrounding? So it is not true that all this water will go like this up to this level, because water is infinite here. So but only under this tube well, due to this pumping out, the level of water has been dropped from here to here. Now what will happen? A drawdown curve will be established. A drawdown curve will be established. This side as well as it would be symmetrical, obviously. Okay, drawdown curve would be established. So due to this pumping, the water level in both of these observation wells would be lower down. Okay, it would be lowered down, isn't it? So what is happening? So there are certain assumptions before I actually get start the analysis and all. What are those assumptions? First of all, we will see that. The first assumption is that the test well, okay, penetrates the entire thickness of aquifer. That is, no flow from the base of the well and flow is radial. Okay, first assumption C. Although this aquifer is unconfined, so if it is unconfined, so it has to be very, you can say, thickness layer is going to be very deep. And if it is going to be very deep, then water may penetrate in my well from here, and it is a unconfined aquifer, and well is only of limited extent, so it may also be penetrating the water maybe from the bottom. This is the reality. But what theme said that we are assuming the moment where our well has been stopped, that is also the stoppage of aquifer, means water is not going to come from the downside. In short, theme said that water flow in this would be only radial. It would not be, you can say, from the base flow and like thing. So he has simply ignored this coming back of water. So as per themes, as per his analysis, only these waters, only radial water is going to be considered. So that is what they say. Test well penetrates to the entire thickness of the aquifer. That is, there is no flow. It is the main purpose. That is, there is no flow from the base of the well, or flow is radial. Okay. So you have to keep this thing in mind. So after some time, if I am doing the derivation, so you should not say, sir, why you are ignoring the bottommost water, because they are being ignored because due to the assumption. Okay, and maybe the percentage of that water coming out from that zone would be quite less in comparison to the radial flow. Okay, that is the thing, man. Okay. Second assumption is quite clear, that flow is going to be your laminar, and Darcy law is valid. Darcy law, I have already told you. What do you mean by Darcy law? Darcy law is itself mean flow is laminar. Okay, your soil is homogeneous isotropic and your flow is laminar. Okay, so your Darcy law is valid. Okay, flow is steady and drawdown is established. Yes, this is also important. So flow is coming here is steady, and we have complete set up the drawdown. Okay, it should not be happen that just after the pumping out we are taking the readings. So it will take some time now from water from B to here, and that would come in this continuous manner. So it will be taking some time. Okay, so we have to wait for some time, and we have to make sure that our drawdown curve has been completely established. Okay. Coefficient of permeability is constant with depth. Yeah, it is also important. Maybe if you are calculating the coefficient of permeability for this ground system for under saturation condition, maybe here the void ratio would be different, here it is different, and here it would be less. So as you are going down, so practically you will be observing that coefficient of consolidation for a same soil, generally it should decrease due to the lesser voids. But in this analysis, what themes had said, that we are going to consider the constant coefficient of permeability throughout the depth. Okay, and yes, one more thing, there is one radius of influence, or you can say zone of influence. Like I can say the zone of influence in this case would be this one. Up to here, because you can say after this radius the original water table is reached. Before this radius, okay, so this radius is known as your radius of influence, means that radius within which okay, that radius within which your water table has been altered, or where all your observation wells are really going to show some deviation, because no point of keeping this observation well beyond this you can say radius of influence, because after that they are going to give the same value as the initial height of the water level, that you already know. So observation wells are only giving you the observations if they are really lying means within the radius of influence, and this radius of influence given by a thumb rule given by Sulzer, so that is equal to R is equal to or 5000 no 3000 under S root K. But it is an empirical equation. It is given by Sulzer, SCHLERDER apostrophe S. So let me write. It is Sculpture's equation, where K is the coefficient of permeability in meter per second, and S it is the drawdown. Okay, it is your drawdown. and this R is radius of influence. R is your radius of influence. I hope till here everything is clear. R is known as the radius of influence. Okay. So yes. So these two observation wells are made to observe the position of drawdown, which must be lying within the radius of influence, because beyond the radius of influence, drawdown would not be established. See, this is drawdown. This is drawdown. It is drawdown at observation well 1. It is drawdown at observation well 2. Okay. The more okay, it is, yeah, I am hiding this. So see this. Observation wells are made to observe the position of drawdown which lies within the radius of influence. Okay, so it was observation well. So just I noticed in my device that I was blocking the statement. So that's why I now have removed myself. Okay. Okay, great. So you can see it. Okay. So see now. So here it is the maximum drawdown, because from here you are pumping the water. This is your test well and this is your maximum drawdown. Let's say it is the drawdown in curve number 1, in observation well number 1, let's say S1. This is your drawdown here, let's say S2. Okay, so this is R1 radius of observation well 1, and it is R2 radius of observation well 2, and this is radius of influence only. This R is radius of influence only. Okay, in that zone where after which your initial water level would be maintained. Okay, anyway, if you are going to take out water from a tube well or some observation well or test well, it is going to influence the surrounding water only. Okay, okay, that's all right. So now you can see the water is coming from here. Okay, and if you are considering this thing, then here the water would be entering. See, it is just like your sphere now. It is just like your sphere. Like, see, this is your center, and this is going to be like this, and this is going to be like this, and for water to come inside, you would be having these things. It will be coming, same thing would happen radially. Okay, so this is going to be the easy. So if you have to consider the area where which is actually available for flow to come in, so that is nothing but the circumferential area of this cylinder, and not with full depth, but only that depth up to where you can find the water. Because water is going to come towards this tube well, towards this test well from up to this height, and from here it is going to penetrate only up to this height, and when it comes and when it is reaching here, it is going to come only at this height. Okay, so let's say this is the value of you can say height. So let me call this height as you can say h1. Okay, and let me call this height let's say h2. Okay, this is the height h1 and that is the height h2. Okay, and for any arbitrary position, I would like to say, for any arbitrary position, you can say at your distance x, let's say y be the height, okay, let's say y be the height. थोड़ा मजा सा नहीं आया, सीधी लाइन बनाते हैं. Yeah, so you can always ask your doubt here. So y be the height at any distance x. Okay, so what is the area which is available for inflow? is 2 pi x into y. Tell me if I am wrong. It is 2 pi x into y. What is 2 pi x? This is x and let's say this is y. So this is a cylinder. So this circumferential area available at radial distance x would be 2 pi x into y. So from this much of area, water is going to come under the gravity flow. Okay. After that we all know that my Q is equal to KIA. This is nothing but your Darcy's law. Darcy's law. So Q is equal to K I is dy by dx and A. Our task is to determine this value. Okay. So but before this, what we can do, we can simply find this discharge, you can say, for a small thing. So Q is equal to simply K dy by dx, and what is area? It is 2 pi x into y, isn't it? So it is going to be like that, 2 pi x into y. So from here you can write that your dx over x is equal to 2 pi k y dy over q, and if you are going to integrate it, because that you are simply considering the small thing, that for this very small change the drop is dy and this distance is dx. So for at this instant the I value is dy by dx, but whenever I am going to do it for a zone, so it has to be more. So on integrating it, I can say that the x is going to vary from your from where to where, let's say from r1 to r2. So at r1 the value was h, and at r2 the value was h2. You can see here, na? So at r1 the value was h1, and at r2 the value was h2, and at any arbitrary distance x the value was y. So if you are going to consider all of them, so you will be getting ln x r2 r1, this is equal to 2 pi k by q, 2 pi k by q upon y square by 2, and its limit would be 2 pi k by q into y square by 2, limit would be h1 to h2. Okay, so it is ln r2 over r1 is equal to pi k over q into h2 square minus h1 square. So k is equal to a q ln r2 over r1 over pi h1 square h2 square minus h1 square. Is it clear? So this is the expression, or if you want to write it in at log 10, at log base 10, so it is 2.303 q log 10 r2 minus r1, okay, divided by pi h2 square minus h1 square. That's all. h2 square minus h1 square. Okay, so that is going to be the concept, or let me write it in here only. I want to write it here only. That is all right. I just trying to increase the visibility. So it is q ln r2 over r1 over k तो हो गया pi अब log हो जाएगा, ये log हो जाएगा। Okay, so this is going to be the coefficient of permeability in your unconfined aquifer. Okay, so tell me if you guys are having doubts so far. If you guys are having doubts so far, then please let me know. Okay, K is equal to 2.303 Q log 10 R2 over R1 divided by pi S2 square minus H1 square. Okay, that is going to be the case. And if somebody asking you what is the Dupit formula, now see why I didn't do Dupit formula. Dupit formula is simply in the same well, you know that this is known as the radius of the well, let's say RW, and that upper limit is the radius of influence. So Dupit method is just an adjustment. It is going to give you the quick result. Why? Because as per Dupit formula, what you can do, you can simply keep your R1 as the radius of the test well only, and R2 you can keep you can say R2 you can use your radius of test or your radius of influence. Okay, so I would like to say that Dupit just didn't consider the observation well. So we need two observation well, na? H1 and H2 height we need, or we need your R1 and R2. So at R1 and R2, R2 is just test well radius. Okay, did I show the discharge? Yeah, I showed here discharge. Okay, it is test well radius and it is radius of influence. So if I want to write here K, then what is the value of K? It is similar only. What is the value of K? 2.303 okay Q log कितना था, कितना हो जाएगा यहाँ पे कैपिटल R over small rw, capital R over small rw. This is small rw, this is your capital R. Instead of these two wells, it simply replaced this to be here and this to be here at zone of influence. And what is the total height at zone of influence? It would be equal to complete, it would be equal to your complete water table height, and it is going to be simply your you can say this is H minus S. This is equal to small height. So let me call it as small h. Okay. So this is the complete h. This is the complete h. So I am placing these units here. You will be getting log capital R over RW into capital H square minus a small h square. That is going to be the case. Capital H square minus small h square. Okay, this is the formula. So simply Dupit didn't consider observation well, and as per Dupit, R1 is this one and R2 is this one. Capital H is the height of the water at radius of influence, and small h is the height of the water at test well, or you can also say that H minus H is the difference of height between them, and it is also equal to drawdown, because drawdown is that full water level minus the available height of the water. the difference of the water, sorry, the difference of the water level is known as your drawdown. Is it clear? Okay, that is the case. Okay, now analysis of confined aquifer. My dear friend, confined aquifer analysis is nothing but a special case of you can say unconfined one. Here the width, or you can say depth B is fixed. Here you can say that your depth B is going to be fixed here. Okay, so that is the case in the confined aquifer, and here the observation well, test well, all are going to sandwich between two impervious strata. So that is the case. So directly I am writing the result here. Confined aquifer, as per themes you can say K is equal to your 2.303. Similar integration and all will be done here. Same diagram, but only difference is B would be fixed. Okay, so Q log 10 R2, same observation well reading, over R1 divided by, here B is constant now, so it is 2 pi B, because the water entrance is always constant, and it is equal to H2 minus H1. Okay, so that is the formula for confined aquifer themes. And similarly, if you want to calculate the Dupit format, then Dupit formula is going to be equal to K is equal to 2.303. Same thing, Dupit is simply replacing R2 by capital R and R1 by radius of the well upon 2 pi B. You can say H2H minus small h. H minus small h is also known as, you know, your drawdown at the test well. Because what is capital H? This small h. So capital H minus small h is also your drawdown. Is it clear? So that is the case. So transmissibility you guys can also find. You can, if K is known to you, after that transmissibility is simply equal to K times of H. Okay, or you can say K times of B. And here as well you can see, here as well, your transmissibility is equal to K times of B, where B is the width of the aquifer, where B is the width of the aquifer, my dear friend. Is it clear? So, is it clear to all of you? So, if it is a matter of confined aquifer, then this is the formula. You must have, you must remember this, because this you can obtain from the special case only. And for unconfined, it is numerator is same. Numerator is same, 2.303 Q log R2 over R1. So only the difference is coming in the denominator. So here pi H2 square minus H1 square, and here 2 pi B capital H minus small h, like this. Is it clear? So like this we can we can analyze our, you can say, confined aquifer. Is it clear to all my dear friends? Okay. So my dear friend, other than these two broadly used field tests, we have several more tests, like some more. Okay, I want to tell you, based on this, you got question. This time you got question in GATE. Okay, GATE में अभी evening GATE में अभी question आया था. I have also did it in my analysis session. I have taken an analysis session, and there I have also did this K value thing. So you can watch that. Okay. So you can see some more test results, or you can see some more test. ओके, स्टील डिज़ाइन के लिए कौन सा बुक सही रहेगा सर? राघवेंद्र, स्टील डिज़ाइन के लिए एक ही बुक चलता है मेन तो वैसे. यू कैन गो फॉर एस के दुग्गल. ओके, गो फॉर एस के दुग्गल. ओके, सो सम मोर टेस्ट आर योर ओपन टेस्ट. Only you should be knowing name. Okay, Packer test, Packer test, and recuperation test. Now, first of all, we are going to take out the discharge, and then we will be allowing water to come back, and we will see how much time it would take. Okay, so that is known as recuperation test. Based on the time taken to fill it completely, we are actually going to find the permeability. So these are some more famous tests, but they are not important from our exam point of view. And this confined and unconfined analysis was really very important. Okay, so I hope you got this. Okay, my dear friend, so let's keep up to here only. So today's session was really very important because we have seen the analysis of confined as well as unconfined aquifer. So in confined and unconfined aquifer, I have tried one case. Then second case is the special case of Dupit. Then third is instead of variable height y, your height of entrance is every time b. So based on that, you are calculating those things. Okay. So guys, it is a complete package to crack GATE and ESE. You can find our subjects here. Okay, SOM, structure, RCC, hydrology, environmental engineering, geotechnical engineering, irrigation. I have also taken geotechnical fresh portion. Fluid mechanics is there, steel is there. And then somebody was asking the book. I would say that was these lectures. You would not be needing books, surveying, hydrology, etc. So this is the evolve batch for GATE 2022, so which is going to start today only. So you can see that our top educators is going to take the lead here, and Ascent batch is also starting for GATE 2023. Ascent batch is also started for GATE 2023. Today is the 5th batch here as well. Okay, and guys, for if you are targeting your ESC prelims, then this is the batch which have already started on 18th. Okay, so you can use my code everywhere. So regarding the prices of and all, you can plan. If you are planning 1 year subscription, then you have to pay 27,225. If you are planning going for a 1.5 year subscription, then 34,650. And if you are going for 2 year subscription, it is going to 39,600. So these are going to be the your plans. And if you are going for iconic one, then 45,225 is the amount for 1 year, and 66,600 is the amount for, you can say, 2 year program. Why iconic is you can say expensive? I have told you this at the very beginning, because at in iconic subscription you can get our your personal coach along with the plus content, and you will be getting the study planning things, test analysis things, daily notes things, practice at things free of cost, or you can say not free of cost, means at some this additional price you are going to get that much of stuff. Okay, so that is the thing why it is on the higher side. And guys, do not forget me to follow on the Unacademy at the rate Sharma Aishwary 1049, and this is the our official Telegram channel, Unacademy CE, Unacademy GATE CE. Okay, so this is a channel where you are watching me right now, which is known as the one-stop solution for all your engineering problem. So thanks a lot, guys. Thanks a lot. I'm going to send this notes very soon in 5-10 minutes in your official Telegram channel. So have a nice day, stay safe, and don't go outside if it is not required. Bye bye.